This is video 1 for the Psych 642 Repeated Measures ANOVA assignment. So I'm going to begin this assignment with a brief description of what repeated measures ANOVA can do, when it should be used, how it works, and what it needs in terms of data and assumptions. So repeated measures ANOVA still tests differences between three or more means, just like the independent ANOVA. The difference is, whereas independent ANOVA looks at means from different groups of people with different participants, the repeated measures ANOVA has the same participants in all of the conditions, or at all of the different time points. The repeated measures ANOVA works similarly to the independent ANOVA. It's still looking at variance and looking at how good your model is compared to how bad your model is. So it's still looking at variance. The difference is, instead of looking at the between group variance, like the independent ANOVA, the repeated measures ANOVA is looking at the within participant variance, and both the variance that can be attributed to your model as well as the residual variance are both going to be located in that within participant variance, which is different from the independent ANOVA. So you're still going to be calculating an F-score. Once again, the only difference is going to be that both the sum of squares for the model as well as the sum of squares for the residual variance is going to come from that within participant variance instead of looking at the between group variance. So what we need in terms of data to run the repeated measures ANOVA is we need a categorical predictor variable with 3 or more levels, as well as a continuous outcome variable. So we also need to measure all 3 or more of the categorical levels with the same participants. So all of that has to be met in order for this test to be able to be used. As far as assumptions, this is still a parametric test, so you still have to test for normality. The independence of observations is going to be broken since you're using the same subjects for each condition. Therefore, this opens up a different assumption that has to be met, the assumption of sphericity, which is the assumption that the variances of the differences between the different treatment levels are equal. So in order to use this test, you will need to test for sphericity and make sure that variance of the differences between the treatment levels is equal. Now I'm going to take a minute to briefly describe the research topic that I will be examining today. I'm going to be looking at whether different amounts of exercise have an effect on depression scores. So I'm going to test this by taking depression scores at the baseline or control level, and then having individuals exercise for 15 minutes a day for 1 week, and then taking depression scores at the end of the week, and then having them do 30 minutes of exercise for a week, and then testing depression scores at the end of that week as well. So I'll be using the repeated measures ANOVA to test the effect of exercise on depression scores in this specific case, because I'm using the same individuals to get all three levels of outcome scores. So now we're going to take a look at the data set, but before I can do that, I'm going to open the script file. It's not what I wanted to do. Before I start working on the data, I'm going to go ahead and load all of the different libraries that have the functions that I'm going to need to complete this analysis. So I'm just going to do that very quickly here. Alright, so now that that's done, I'm going to go ahead and clear the console so things don't get super messy. And I'm actually going to input the data for this by hand. So to do that, I'm going to have to create each variable. So the first variable is going to be participant, and I'm going to use the GL function to create this. So the GL function has you specify the number of levels and the cases in each level, which I have 18 participants, so that'll be the number of levels, and then the cases in each level will be 3, because there are 3 levels of exercise that I mentioned that each participant will be involved in. The control 15 minutes of exercise and 30 minutes of exercise. And then you specify the labels for each level, which you can see I've done here. The second variable is exercise. And once again, I'll be using the GL function. So the number of levels, like I specified up here, is 3. And then the cases in each level will be 1, because each participant in each level will have 1 observation. And then the total cases will be 54. So we're going to have a total number of observations of 54 throughout the whole experiment. And then once again, just setting the labels to the 3 different groups of exercise to control 15 minutes and 30 minutes. And then finally, I'm going to create the variable of depression, and it's just going to have all 54 of the outcome measures of depression. So I'm going to go ahead and run that. So creating participant, exercise, and depression. So now that all the different variables are in there and properly defined, I'm going to use the data frame function to compile them all into one data set. Okay, so let's take a look at what that looks like. So you can see that the data is in the long format, which that's the format that's required to run the repeated measures ANOVA. If the data had been in an Excel spreadsheet in a different format, we could have done something like use the melt function to convert it into this format, but I found that it was easier just to input the data in this fashion than to use those functions. So before I start creating any models or running any type of analyses, it's best to start off with checking some assumptions as well as just getting a broad picture of what the data looks like. So the first thing I'm going to do is I'm going to graph the data. I'm going to create a bar chart that shows the 3 different means for the control, 15 minutes of exercise and 30 minutes of exercise. So let's do that now. So I've used the ggplot function to specify the data that will be used in the graph, and then I've used the stat summary function twice to specify the graphical elements, the visual elements of the graph, both the bars themselves as well as the error bars. And then I've also used the labs function to set the X and Y axes labels. So let's take a look at what that graph looks like. So you can see that both of the groups that had some exercise do seem to have somewhat lower scores on depression, but these two are very, very close together, so there doesn't appear to be a very big difference at all between 15 minutes of exercise and 30 minutes of exercise as far as the effect that it has on depression scores. So next I'm going to actually get some descriptive statistics so that I can see the means and standard deviations and things like that. And I'm going to use the by function paired with the stat.dsc function to look at the descriptive statistics of the depression scores grouped by the amount of exercise. And you can see that output down here, where once again we can see in numbers that these are very close together as far as the mean depression scores, whereas this one is a bit higher at the control time compared to the time after the clients have done some form of exercise for a specific amount of time. So I'm also going to test the assumption of normality, once again using the by function, but instead of the stat.dsc function to get descriptive statistics, I'm going to test for normality of the depression scores for each of the levels of exercise. So I'm going to run that. And we can see here that each grouping of scores does not differ significantly from the normal distribution, so we do meet the assumption of normality.